Welcome to class, chemists. Boy, have I got a good joke for you. A neutron walked into a bar and asked how much for a drink. The bartender replied, "For you, no charge." Did you laugh as much as I did? If not, don't worry. You'll understand it by the end of this unit. So we are in Unit 2, the building blocks of matter. A lot of this is going to be reviewed from your middle school science class. So here are our objectives for this lesson. Identify and describe the discoveries and research of Democritus, Dalton, Rutherford, Thomson, Millikan, Bohr, and Schrodinger. Basically, we got to learn some stuff about some old dead guys. Second objective, describe the law of conservation of mass and law of multiple proportions. You've learned law of conservation of mass before, so don't worry about that one either. Third objective, describe the atomic theory and its individual components. So we're going to learn all about the different parts of an atom here. Again, stuff that you probably know, so don't stress this unit. You're going to be great. All right, Democritus versus Aristotle. They were both Greek philosophers. Aristotle viewed the entire known universe as being made up of 5 distinct elements, as he called them. They were earth, fire, air, water, and ether, which mix to form anything of substance. Democritus coined the word atom, or atmos as he called it in Greek, and he said that if you break a piece of matter, just anything, break it in half again and again and again and again, before you break it no more into a smaller possible bit, that piece is called atom. People believed Aristotle for almost 2,000 years and thought Democritus was kind of crazy. Even though now we know Democritus is much closer to correct than what Aristotle was. All right, another big important dead guy, John Dalton. So he was an English chemist, meteorologist, and physicist. That's pretty impressive, 3 super careers. So he decided that atoms are tiny hard spheres, and I like to think of this as somewhat like bouncy balls. Very tiny bouncy balls. So he thought they were tiny, hard, there was nothing in between, there was no spaces, it was just one thing. He used his ideas and the ideas of scientists before him to come up with his atomic theory. His atomic theory has several parts. Okay, so first, 1803, Dalton created the atomic theory. The atomic theory said this: 1. All matter is composed of atoms, so everything that we can touch or feel, and some that we can't, are made of atoms. Atoms of a given element are identical in size, mass, and other properties, which is almost correct. And atoms cannot be subdivided, created, or destroyed. This is the law of conservation of mass, meaning that they can't be created or destroyed. And the subdivided part has been disproven. Whenever you subdivide an atom, we call this nuclear fission. And it creates a lot of energy. Atoms of different elements can combine in simple whole number ratios to form compounds. This is called the law of multiple proportions. Essentially what this means is that, let's say that you have carbon atoms and oxygen atoms. You can have 1 carbon and 2 oxygens. You could have 2 carbons and 5 oxygens. You could have any whole number. What you can't have 2.5 carbons and 6 1/3 oxygens. That is not possible. So that's all the law of multiple proportions is telling us, is that you're going to have whole number ratios. And his 5th postulate was that in reactions, atoms are combined, separated, or rearranged, meaning they're not created or destroyed, they're just combined in different ways. Now these 5 postulates are going to be massively huge in understanding chemistry, so I might study them a little bit for my test. All right, next old guy we're going to talk about, J.J. Thomson. His research was in 1897. He discovered the electron. So electrons, what's important about them? They are negatively charged. He used the cathode ray and found that the negatively charged portions were deflected when going through a magnetic field. So if we were dropping something in, let's see, if we're going this way, it's going to deflect this way through a magnetic field. Maybe it's going to deflect this way. Whatever happens, we are going to not go in a straight line because we're in a magnetic field. So he came up with the plum pudding model, which looks kind of like this. Most of us have not had plum pudding, but it's also kind of like walnut brownies. And he thought that an atom was just a large, mostly positive sphere with a few little negative electrons sprinkled in between. Kind of like a large chocolate section of brownies with a few little pieces of walnuts sprinkled in between. Robert Millikan studied in 1910 with an oil drop experiment to discover the charge of the electron. to confirm that it was actually negatively charged. So here's how that worked out in brief. Oil droplets are atomized, meaning turned into atoms. They go through a charged metal plate, which is positive, and an X-ray source that produces ionizing radiation. There's a microscope to look at what happens, and then there's a charged negative plate on the bottom. Now, you have the charged oil droplet right in here. What happens is that if the electron is negative, it should go toward the positive plate. If it was positive, it should go toward the negative plate. But since it was negative, it went toward the positive plate. All right, next dead guy we're going to talk about, Ernest Rutherford. In 1911, he discovered the proton and a nucleus by hitting gold foil with helium particles. Helium particles are also called alpha particles. What he learned was that most of an atom is empty space. Whenever he hit the gold foil with the fast-moving helium particles, he figured out that it would deflect where the positive portion was. So we'll look at a picture on the next slide. But it would bounce off in the nucleus, but for most of the time, the alpha particles would pass straight through because the atom was mostly empty space. So he concluded, and this is the really important part here, he concluded that there was a very small, dense area in the center that was positively charged, and the rest was empty space. So what you need to know about Rutherford is he discovered the nucleus and the protons. All right, gold foil experiment. So if you're shooting positively charged alpha particles towards this gold foil, if there's mostly empty space in the atom, then you're going to have all of these alpha rays go straight through. But whenever you hit the nucleus, you're going to have some deflections, meaning it could go this way, these alpha particles could go all these different directions. But for the most part, most of it was going straight through. So that's how Rutherford knew that most of the atom is empty space, because those alpha particles could pass straight through. All right, and next came Bohr in 1915. He studied gamma rays, pointed at hydrogen-containing compounds, and found that something was in the nucleus besides the protons. What he found in there was the neutrons. And he figured out that they have no charge, which led to the Bohr model. The Bohr model, I'm sure you've practiced these before, is where you have your protons and your neutrons in the center, and then in circles around you have your electrons. And then in 1925 we had Edwin Schrödinger. He studied electrons and their behavior and determined that the electrons have what we call dual wave properties. Now what this means is that they can act like a wave or they can act like matter. So they act like matter because they have mass and volume, but they also act like light waves because they can be bent or diffracted. This became known as quantum theory and was the introduction to quantum physics. Okay, so let's update our timeline. So in 370 BC, Democritus coined the term atom. Way long after, almost 2,000 years later, in 1803, Dalton came up with his atomic theory, and he had those 5 postulates. In 1871, Mendeleev created the periodic table. We haven't talked about him yet, but we will definitely get there. In 1890, J.J. Thomson discovered the electron. In 1910, Millikan discovered the charge of the electron. In 1911, Rutherford discovered the proton with his gold foil experiment. 1911, Moseley rearranged the periodic table. We also have not talked about him yet, so let's just go through our guys we haven't talked about yet, but we are getting to them. 1925, Schrödinger discovered the dual wave particle theory for electrons. And 1915 through 1932, Bohr and Chadwick discovered the neutron. We'll talk more later about how Chadwick also contributed to this neutron discovery. All right, that's the end of this lesson right now. Thanks for watching, guys. I'll see you soon.